Alrighty, welcome back to the channel, everyone, and welcome to part 3 of the Cloud Portfolio series, where I'm showing you how to build and deploy a cloud application from scratch. In this video, we're going to be building out your database and your backend API, and if you missed parts 1 and 2, make sure to go check those out for some instructions on how to set up your machine for this project, and also to follow along with us as we built out our static website and front end. Now, taking a look at some of the requirements that we pulled together in part 1, we're going to be knocking out these two middle requirements here, which are we're going to be standing up a Cosmos database to store our active view count on our portfolio. And then we're also going to be building out an API layer that will interact with that database. Pivoting over to the process flow diagram, again, we wrapped up our static website in the last video. So we're going to be focusing down here on building out our Azure function, which will act as our API layer. And it will be making calls to our Cosmos database, both getting and updating our active view count. And then our Azure function will be returning that active view count back to our static website. Okay, so I want you to go ahead and open up Azure portal, do a search for CosmosDB. We're going to be creating a new Cosmos database account. You can just go ahead and click create here, and then go ahead and choose the default, which is Azure Cosmos DB for NoSQL. And okay, so it's going to ask us for a couple things here. You can just use the default subscription. If you completed part 1 of this series, you are already going to have a default subscription. You can use that. I do recommend you create a new resource group here. Basically, for everything we build going forward in Azure, we are going to assign it all to this resource group, just so it's all nicely bucketed under a single resource group. I'm going to call it Cloud Portfolio RG. And then we need actually a name for our database account, which I will call this the Cloud Portfolio DB account. We can leave availability zones disabled. Choose the location that's geographically the closest to you. For me, I'm in Austin, Texas, so it's South Central. But just, look through these options and choose what's the closest to you. There's really no wrong answer here. If you get this wrong, it's really not going to have much of an impact. We're not building an extremely high throughput, low latency system here. So you shouldn't even notice if you choose a location that's not extremely close to you geographically. Okay, what is important here is make sure you choose serverless for your capacity mode. This will just make sure that we're only paying for what we're using. And you can see here it's billed only for consumed RUs, basically saying that it's only being billed on request units. So throughput. And again, I doubt this is even going to cost us a penny. We're not going to be calling this database enough to really put a dent in any of the cost implications here. All right, so go ahead and review and create. Let's just look and make sure that we have everything set up right. So we got our resource group, Cloud Portfolio RG is creating it new. We're in South Central. We're creating a new DB account, and we have it set to serverless. All right, let's go ahead and create. That all looks good. And it says it's going to take about 1 minute. I found that this, takes a little bit more than 1 minute. I think Azure is being a little bit, they're not quite telling the truth there. So while this is building, let us go ahead. There is one thing that I wanted to show you guys. It's not necessarily pertinent to this project, but it's just good to know as a cloud engineer in general. And I don't see a lot of videos really discussing this. And I'm going to show you guys how to set up a budget on your Azure account or your subscription. So what you can do is you can come up in here to budgets, which you just search budget and you can find it. And then go ahead and let's add a new one. And we will call it portfolio. Let me spell that right, portfolio. And I'll just say every quarter, I don't want to spend more than $2, okay? Let's go next. And then we can actually set an alert if our forecasted cost is going to be, for example, I'll say maybe 10%. So if we end up spending 20 cents or we're forecasted to spend 20 cents, this will actually send us an alert to our email. Again, this is not really relevant for this project. A lot of you are probably using your free credits from your new Azure account. And even if you weren't, this is not going to cost more than at the very most $1 to set up and run for a year. So more so just showing you guys this because I've seen this used on a lot of different cloud projects in the real world. And I think it's a cool little thing for you guys to know about. It's definitely best practice to make sure that you're monitoring your costs and you don't get a giant Azure bill at the end of the month that you weren't expecting due to a runaway service, or maybe you decide to extend this project and you make a mistake in your code and end up creating some sort of a performance issue. This will catch that and send you an email so that you can come back in and clean it up as soon as possible. All right, so this is still creating. One other thing I wanted to show you, you can open up the resource group here. And you can see now, like this is showing everything that's inside of that resource group. Obviously right now it's just our database account, but going forward, we're gonna be creating some more infrastructure in Azure that will all be associated with this resource group. So you can go ahead and bookmark this. That's probably a good thing to do because it's just a really clean way of seeing everything that we're gonna be building out in Azure as part of this project. All right, let's go back. Looks like our deployment is still going. Again, if they said 1 minute, I think that was a little bit longer than 1 minute. Okay, looks like it just finished. So we can go ahead and let's open this up. Let me go back to Cosmos database. It should show it here. Oh, looks like it didn't. Let me refresh. There it is. Okay. So we've got it pulled up now. So the next thing we want to do is we actually want to go ahead and create our database inside of this database account. And we also want to create a container that will be storing our item that will be holding the view count of our portfolio. So you can click new container here, data explorer, new container. I'm going to call the database the cloud portfolio DB. Our container name, I'll just call it counter. And then our partition key, this just needs to be something that kind of is unique and identifies each individual item or record. I'm going to use ID. I would suggest that you kind of set this up similar to me so you can follow along. And then, okay, so we can go ahead and create this. So this will be creating both the database and the container that will be housing our item, which will be responsible for tracking the view count of our portfolio. And once this gets created, we will go ahead and create that first item. That'll be the next step here. Shouldn't take it too much longer. There we go. Okay. So we've got our database and then we have got our container. Let me kind of collapse some of that. There we go. We've got our database, we've got our container, and then we have the items in that container. And you can see we have no items, which makes sense. We just created this container from scratch. So let's go ahead and create a new item. And okay, so it gave us an ID, which makes sense because we set that as the partition key for this container. So every single item in this container has to have an ID field or attribute. So I will just set this to 1 and then let's think. So we want to make sure we have a count. So let's store our count here as well. And this will be what ultimately gets incremented via an API call when we refresh or reload our portfolio. Okay, so I think this is looking good. I think we can go ahead and save this. It'll add some metadata to your item. Don't worry about this. This is not really relevant to this project. You can just ignore it for now. And then what we want to do next, we want to go ahead and create our function app now, which will be basically responsible for querying and updating this database. And we can either create the function app directly through Azure portal, or we can create it through Visual Studio Code. Since we're going to be writing our code in Visual Studio Code, I'm going to go ahead and create it there as well. So go ahead and open up VS Code. You want to choose on your machine where you actually want to store this function app. If you have been following along through the past couple videos in this series, put it in the same directory or repository that we use for our front end. You can go ahead and open that up, and then let's go ahead and just move all of our front end stuff that we did into a front end directory just to kind of clean it all up and separate it from our back end code. Okay, so we'll drag that into front end. Looks good. All right, nice. So now let's go ahead and create a backend directory, which will be where our function app lives. Oops, let me see, new folder, backend. All right, so now what we want to do, so we need to get the function app extension in Visual Studio Code. So let's go ahead and add that. That'll be just responsible for standing up a lot of the framework and infrastructure for us. So install the function app. And then you can see I just got this Azure icon here. And then I can click on that, click create a new function project, choose that backend directory, and we want it to be in C#, .NET 8. If you have not already configured your machine to run this, go back to video 1 or part 1 in the series, and I walk through how to do that. And then we want an HTTP trigger. Basically, what an Azure function is it's just a cloud-based way of running a really small piece of code based on some event. One way I think about it is it's like a little mini program that is sleeping until it receives an event, and then it wakes up, it does some processing, and then it goes back to sleep. That is kind of the, summary of what serverless is. And it's nice because we don't have to worry about managing any of the infrastructure. We can just focus on writing our code. So for our specific use case, we want this to be an HTTP trigger because we want that event that wakes up our function to be an API call or an HTTP call. So go ahead and choose that. We need to give it a name. I'm just going to call it visitor counter function. That sounds good. And then we also want a namespace. I'm going to give it the same name. Namespace, it really is just a way of kind of organizing your code. And then give it just the default function access rights. That'll make it easy for us. All right, so this will go ahead and create our function app. Nice. So you can see now inside of our backend directory, we now have some new code, which was created by that extension. And if we take a quick look at this, let's see. So you can see we've got a function defined here. We've got a run method that gets invoked or called anytime there is a get or a post request to this function. And then it goes ahead and writes out a quick log and then returns an OK object result or a 200 level response with a little bit of a message here for us as well. Okay, so we can go ahead and actually run this locally and just make sure this is all working. And to do that, you're going to want to cd into your directory where you have your function app created, and then run a func host start. And that should go ahead and start our function app. And it should also give us a URL that we can go to actually invoke or call our function app. Yep. Let me go ahead and open up Chrome, paste this in. Nice. You can see we've got our welcome message here. Welcome to Azure Functions, which is the message that we were seeing here in our code. Okay, so a couple things that we need to do now. Let's go ahead and write these down just so we have something to follow. So steps. Step one is going to be, you can see I have GitHub Copilot installed as well as an extension if you want to add that. It's not really helping us out much here, but it's giving me some of that like IntelliSense and trying to, use AI to be smart about predicting what I'm going to write here. So step one, we are going to want to query our CosmosDB. Step two, we are going to want to increment the counter in the item. Increment the counter in the item. Then step three, we want to update the item in CosmosDB. And then step four, we want to return the updated count. Perfect. Okay, so I think these are some good steps for us to follow. We'll be working through these for the rest of this video. Up here at the top, so we need to query our Cosmos database. We can do this through a function binding, which is really just some shorthand or kind of like some syntactical sugar that allows us to wire in functionality into our function apps in a pretty easy way. And what you can do is you can just do a Google search for Azure function bindings CosmosDB. We're on the newer version of our Azure functions, so function 2 and higher. And then over here, input. So the input will kind of be, it'll be the record that we are ingesting or querying. And if I scroll down, we should see a little bit of a code sample. Yeah, here we go. So you can see this is our binding. It's a CosmosDB input binding, and it takes our database name, our container name, our connection string, and then the ID and the partition key of the item that we are wanting to query. So I'm going to go ahead and copy this. Let's go ahead and grab this. We can bring this back and put this into our code. All right, I pasted that in. And this looks like, is this working? One thing I also am going to do real quick, I'm going to add the C# dev kit as an extension. If you don't already have this installed, go ahead and install this. It'll give us like some feedback on our code. Okay, so I installed that, and yeah, okay, here we go. So now we're seeing these little red squigglies, which is telling us like, hey, something's wrong. I was expecting to see that earlier. I was a little bit surprised. Yeah, you need to make sure you add the dev kit. Okay, so let's go ahead now. The reason that it's complaining about this CosmosDB input is because even though we are referencing that binding, we need to import the library or the package that gives us that binding. And we can do that through a NuGet package. If you look up here, yeah, so this right here, worker extensions, this is the NuGet package. And basically all NuGet is it's just a package manager. It allows you to pull different packages and libraries and different functionality into your projects. Go ahead, copy that. Let's go back to our function app. You can click Control-C to kill the current instance of your function app. And then let's run this .NET add package command here. And all right, so that should give us the CosmosDB input. Nice, you can see now that it removed those red squigglies, basically telling us that it's happy with this. And okay, so it's not happy with to-do item. We'll clean this up. That makes sense. We do not have a to-do item defined in our code. So we will need to basically create an item that maps to the database item or the database schema that we have established in Cosmos database. But before we do that, let's update some of these attributes here. So we need it looks like our database name is Cloud Portfolio DB. Our container name is counter. Our connection. Okay, so our connection string is going to live in this local settings.json file. This is really just a way to inject different, environment variables or secrets into your application. And we want to make sure that the name is the same, CosmosDB connection. Okay, so that's the key. And then the value will actually be our connection string. And to get your connection string, just go into Azure portal. Let's open this back up, just this one. And under settings, there should be, a keys option. And then if we scroll down, you can see primary connection string right here. Go ahead and just copy this. All right, and then we're gonna paste that in here. Okay, so there's our connection string. And then, okay, so the ID of the item we're fetching is 1, and the partition key of the item we're fetching is also 1, because we just have a single item that we're using to basically represent the count of our portfolio. Okay, let's see. So next thing we need to do, so we need to actually model a class in our C# code to match the schema or the shape of the item that we have defined in our database. So to do that, let's go ahead. I'm going to create a new folder called models, and I will give it a name. We'll call it visitor counter item.cs. That'll be a class. And let's go ahead and define this public class. Looks like it's given me some IntelliSense. This is actually pretty close. So we do not have our partition key to worry about. We just have ID and count. Let me double check real quick. I'm pretty sure ID is a string and count is an integer, but let me just make sure that is correct. So if I open up the container, yeah, so ID is a string, count is an integer. That looks good. All right, so let's go back. One thing we are going to do is let's just explicitly define the JSON property name, just so we don't have to deal with any sort of like weird deserialization or like casing issues when we're deserializing from the database item into our .NET model here. And okay, so item, this is ID, count. Okay, I like that. That's all looking good. So now we can come back in here and replace this with visitor counter item. That is looking good as well. And then we can name this visitor counter item. All right. So based on everything we just wrote, we should now have a fully functioning input binding. So this should actually be querying our database. I'm going to kind of move this all on one line to save some screen real estate here for our actual function code. Kind of just make this look a little bit cleaner. All right, let's do that. And now we're all on one line. Perfect. And to test this out, to just make sure that this query actually is working, let's change the response here on our Azure function to return this is the count. And then we can have it return the current count. That looks pretty good. Yes. Okay. Let's go ahead and do a func host start. This will start our Azure function. And then what I'm hoping to see is this returns a count of 0 because we defined that count to be 0 in our database. Okay, we'll go back. And I've already got it open here. Very nice. Okay, so this is the counter and it's set to 0. That makes sense because in our database, the count is currently 0. So this looks to be working. It looks like we have got the query wired up correctly. So we can go ahead and cross off step 1. We have done that. I'll just put in, I'll just actually like cross it out or get rid of it. Okay, so next we need to increment the counter item. And before we do that, I'm going to get rid of this logger. This is just adding like extra bloat. We don't need a logger necessarily. I may do like a follow-up series doing more advanced concepts and talk through like observability and monitoring for different types of resources. But for now, let's just rip that out. And then we actually can get rid of the constructor as well because we're not injecting in a logger now. All right, so back to incrementing the counter. What you can do here, so we could do, visitor counter item.count ++. That would increment it, and then this would return 1. But this is not exactly what we're looking for. This is getting us close. Let me just make a note, increment count. And okay, so the problem here is that, so an API call will be made. It is going to query our database for this item with the ID of 1. It's going to return a count of 0. This is going to increment it to 1, and then this is going to return 1. But nowhere are we actually then turning back around and updating or writing the new count back into our CosmosDB container. So that's kind of what we're missing here and what we need to be doing. So let's go ahead and wire that up. And to do that, we're going to go back to our function bindings. Again, there should be, yeah, we've got an output binding, which will be responsible for updating our item. And if I scroll down, okay, here we go, CosmosDB output. This looks pretty good. Takes the database, the container, and looks like the connection. Yep. Okay, so I'm going to copy this over, and you notice this is actually on top of our run function, so let's make sure we adhere to that. We're going to throw this here. And then I'm just going to update this with the actual names of our stuff here. Our connection's the same. We don't need creative not exist. This basically would create the container if it doesn't already exist, but we know our container's there, so I'm just going to get rid of that. That just seems like extra weight. Okay, so now that we have that, so now what we should be able to do, let's go back real quick. So how does this work? Okay, yeah, so I see. So what it's doing is basically whatever is returned from this function is what is getting written to the Cosmos database. So we basically want to return the updated visitor count item from this function, which then behind the scenes will go ahead and write the updated record or the updated item to our database. Okay, so we can do that, but it's going to be a little bit weird because this, this method currently returns an iAction result, so it's returning like an HTTP response. So we can't just like return it at the bottom because we also need our HTTP response for our front end to read so we can properly display the visitor count on our web page. So I'm going to change this to a task that returns a visitor count item. Okay. And then we'll make this asynchronous. And all right, so now we can return visitor counter item here. Okay, so now this actually would probably work. We can actually test that out. Let me do that. Let's actually test this out. This should, even though we're not going to get a response back, this should still increment the count in our database if this is all written correctly. Okay, so we'll do a func host start. And we will call our API. And again, we're not actually returning an API result, so it's just going to give us an empty response. At least I think so. I don't think it'll throw an exception, but we're about to find out. Okay, yeah, so it just returned an empty response here. That's kind of what we expect. Okay, so now I would expect this count to go to 2 if we refresh it. And I think to refresh it, we can just close and then reopen. Okay, so the count was actually 0, so it went to 1, so that makes sense. So let me refresh this. So it's 1. I'm going to refresh it. It should be 2, 3, 4, 5. So this should be 5 now. And perfect. So our count is now 5. Okay, so we are now properly reading and writing to our database. And the last thing we need to do here is we just need to figure out how to write an HTTP response. And to do that, so we currently have this, we're using this ASP.NET Core HTTP request object. There is an object where you can kind of tap into the HTTP context of your Azure function, and we're going to use that. HTTP request, I think data. Is that real? Let's see. Is it going to let me import that? Yeah, there we go. Okay, so this is part of the functions worker runtime. We're going to want that. And then from here, we can do like var response equals, request.create response. And then I think we're going to import system.net. Yep. And then we also want to, perfect. We want to then write out our response. We don't want to write a string. I think we want to write JSON, write as JSON async, and then we're going to return our visitor counter here. So this should return the updated visitor counter here, and then right below that, it'll write to the database. Okay, let's go ahead and give this one more try. So same as before, we should see the visitor count incrementing, but then this time we also should see it returned to us through our API call here. Perfect. Okay, ID1 count 6, ID1 count 7, ID1 count 8. Okay, nice. This seems to be working exactly as we're expecting. All right, so I think we're pretty much done here. Let's do a little bit of cleanup. What else do we have? Okay, so this doesn't need to take a post request. We're just making GET requests, so we can get rid of this right here. Everything else looks pretty good from what I can tell. I'm going to remove some of these unused imports. Let's save that. All right, and I think we're good to go ahead and push this up to our repository. So let's go ahead and do that. If you followed along with me in part 2, you've already got the GitHub repository stood up. So you can just do a git add-a, give it a commit message. I will say adding backend, and then we can go ahead and do a git push, and this should push this code up to our repository. And let me go ahead and open that real quick. GitHub, and it is this one, Azure Cloud Project right here. Oh, no, wrong one. Sorry about that. It is actually this one, the first one I was on. And you can see, yeah, so you can see we have our adding backend commit. It just came up now. And you can see we've got our backend code. And if I drill into this, we should also be seeing the Azure function here. Very nice. Alrighty, guys. Well, that is the end of part 3 of this series. We have successfully created our database and our backend API. In the next video, we are going to be standing up some CI/CD pipelines and getting our code deployed up to Azure so we can finally start putting a bow on this project. I look forward to catching you guys over there. See ya.